This lesson is on equivalent fractions. Equivalent means equal. So equivalent fractions are just different names to describe the same part of the same whole. For instance, if you take a look at this pizza, you might say to yourself, well, it looks like half of the pizza is missing. I would write that as 1/2. However, you can also see that it's been divided into 6 pieces on the actual tray. So you might also say that 3/6 of the pizza is still there, or 3/6 is also missing. So therefore, 1/2 and 3/6 are equal or equivalent fractions. Let's take a look at a problem using equivalent fractions. So our problem says that Mary planted 2/3 of her planter with daisies. Jane planted 4/6 of her planter with daisies. The planters are the same size. Did they plant the same amount with daisies? Well, one way to solve this, again, just like we did when we compared fractions, is to come up with a model. Whenever you're trying to solve a problem with fractions, it's always best to use a model. Because the planters are the same size, we can use 2 of the same size rectangles to represent the planters. Now, Mary planted 2/3 of her planter, so we see that her denominator or her bottom number is 3. So we're going to want to split Mary's planter into 3 equal parts. Jane planted 4/6 of her planter, so her bottom number or her denominator is a 6. So we're going to split her planter into 6 equal parts. On the left-hand side, we see Mary's planter. She has planted 2/3 daisies. On the right-hand side, we see Jane's planter. She has planted 4/6 of her planters with daisies. We can see that even though the planters are both broken up into different equal parts, the same amount of the planter has been covered in daisies. Therefore, 2/3 is equal to 4/6. These two fractions are equivalent or equal. To make it a little bit clearer, if you see Mary's planter here with 2/3, if we were now to split this same planter of Mary's into 6 equal parts, then we have 4/6, which was Jane's planter. Here I have a rectangle split into 10 equal parts. So the fraction that I have shaded is 2/10. Now, if I take this same rectangle and I keep the exact same amount shaded, but I take away that middle line, and instead of having it in 10 equal parts, I have it in 5 equal parts, then I will get the fraction 1/5. So you can see that just by taking away that line, I didn't change the area of the shape. We're still using that same fraction of the area, and we still have the same portion shaded, but now we see a different fraction. So 2/10 is also equal to 1/5. Now let's view equivalent fractions as fractions of a set instead of fractions of an area. So in fractions of a set, remember, we don't have one shape, but we have a collection of shapes. So in this case, we're showing 4/6. 4 of these 6 counters are black. So instead of having one shape again, we have a collection of shapes. Now we can still show equivalent fractions using this. In this second scenario, we're showing 2/3. What we've done is we have split up the original 4/6 into a denominator of 3. So now we're looking at 3 areas. We're pretending that this is 1, this is 2, and this is 3. So instead of having all 6 sets, we now have 3 sets. So these 2 sets here are shaded and the other is not. So we'd say 2/3 of this set is shaded. Therefore, 4/6 is equivalent or equal to 2/3. Now let's take this a little step further. As you get older, you won't necessarily be showing models to show equivalent fractions, but you'll actually be multiplying and dividing to show equivalent fractions. So I just want you to see how that works. In our first show, we have 2/3. Basically, what we've done to make 2/3 4/6, if we multiply the top number and the bottom number by 2, we get 4/6. So we've essentially doubled it. By putting the line in the middle of the shape, we've doubled the area of the shape, or the parts of the shape, I should say, not the area. We've doubled the parts in the shape, and we did that by multiplying. Just remember, whenever you work with a fraction, whatever you do to the top number or the numerator, you also have to do to the bottom number or the denominator. It works the same way if you go backwards, if you want to make a bigger shape smaller. So if I had taken the number 4/6 and instead of doing the multiplying, I'm now dividing the top number and the bottom number by 2, then I end up with 2/3. So you can work forwards or you can work backwards by multiplying or dividing to find equivalent fractions. Let's do another example showing that. So my first fraction is 1/2. And what I'm going to do is I'm going to multiply the top number and the bottom number by 2 to get the equivalent fraction. If I multiply 1 times 2, I get 2. And if I multiply 2 times 2, I get 4. So 1/2 and 2/4 are equivalent fractions. They are equal to one another. Now in the second example here, 5/10, let's go backwards. Let's try to divide. Now when I divide fractions, remember it doesn't always have to be by 2. When I'm doing equivalent fractions, it doesn't always have to be dividing or multiplying by 2. I can pick various numbers. When I look at 5/10, I'm thinking to myself, well, what number would go into both of those numbers? Well, I know 5 is divisible by 5, and so is 10. So instead of using 2 this time, I'm going to use 5. So I'm going to divide both of these by 5. 5 divided by 5 gives me 1. And 10 divided by 5 gives me 2. So 5/10 is equal to 1/2. They are equivalent fractions. Now, if you want more proof that 1/2 and 2/4 and 5/10 and 1/2 are equivalent fractions, we can show it with a model. So you can see I have a rectangle. So if I were to split this rectangle in half, or as my denominator says right over here, 2 equal parts, that is showing me 2 equal parts. And if I shaded in the top, that would be 1/2 of that shape. Now, I can still take that same shape and I can divide it into fourths. So I would add another there and I would add another there. Now I'm showing 2/4 because I still have the same amount shaded. 2 of my squares are now shaded out of the 4. So that shows you how 1/2 and 2/4 are the same. Now down at the bottom here, I'm going to show 1/2 as well. So I'm going to split that rectangle into half to show my 1/2, and I'm going to shade 1/2 of that rectangle to show it. Now, the next thing I have to do is I have to split this rectangle into 10 parts to show 5/10. Now I've split the rectangle into 10 equal parts. I know my middle one's a little bit bigger, but I'm drawing this freehand. Obviously, you want your parts to be equal. I still have the same amount shaded, but now it's 5 parts that are shaded and a total of 10. So that shows you how 5/10 is equal to 1/2. They are equivalent fractions. Let's do one more example. So you can see in my first picture, I have a total of 1/3 that is shaded. And in my second picture, I have 3/4 that are shaded. Now, I want to make equivalent fractions. So what I'm going to do is I'm going to split this first shape up. Now instead of 3 parts, I have 6 parts. So my new denominator will be 6. And my new numerator, I now have 2 out of those 6 parts shaded. Same thing with the bottom. I'm going to split this up a little differently as well. I'm going to add a section here, and I'm going to add a section here. So now, instead of having 4 equal parts, my shape actually has 8 parts. And now there are a total of 6 parts that are shaded in. So therefore, at the top, 1/3 is equivalent to 2/6, and 3/4 is equivalent to 6/8. Now basically, all I also did was double the shape. So let's look at the way that we did it in the last example where we actually showed the multiplication. So if I take 1/3 and I multiply it by 2, when I multiply the top by 2, I get 2. And when I multiply the 3 by 2, I get 6. Same with the bottom. We doubled that shape. So if I multiply 3 by 2, I get 6. And if I multiply 4 by 2, I get 8. So that is one way of showing the equivalent fractions. If I had started with these larger numbers over here on the side, and instead I divided them by 2, then I would end up with the other number that we started with. So equivalent fractions can go back and forth. It doesn't always have to be 2. I know this example showed multiplying by 2 again, but basically you are just trying to make fractions a little bit bigger or a little bit smaller without changing the area of the shape. You just split up the parts into different equal parts and you don't change the shading.